Hey guys, so today we'll be discussing few problems related to again the sliding window. So let's go through them and see what all optimizations we can make. So let me share the screen then.
Okay.
Hi Santosh. Yeah.
Mhm.
So yeah, let's start with this, right? So this is like your shortest subarray with sum at least k. So you are given an integer array nums and an integer k, and you have to return the length of shortest non-empty subarray of nums whose sum is at least k, and if there is no such subarray, then return -1. And this is just the definition of a subarray, right? You can see like here, yeah, I mean there is single element. You want a sum of 1, so this is possible. Here the sum is 4, so it's not possible, right? At this point, the entire subarray. This is the size. Yeah, and these are some of the constraints. And one thing is like the array will have negative numbers also. So that part we have to take care. So what do you guys think here we should go with?
So can you scroll up
Sure.
the problem? So what does it say? Up to k with a sum of at least k. So anything below k also is fine.
No, above k. At least k should be satisfied. Above k and above than k, more than k.
Okay, and more than k. Okay.
Yeah. So one way is like if we go by the normal sliding window, right? Like the way we do, keeping both the left and right pointer at this place and keep on expanding the right window, right? Till you get a sum of this k, right? And then you start shrinking the window to check if there is any valid window which is lesser than that. That won't work here, right? Because the numbers are negative here also. So the moment you try to increase your array, it might be possible that you might not get a monotonic sum, right? It might decrease also, increase, decrease, something like that. That behavior won't be there.
No, so should we think about sorting here?
Order will
Is
change.
important subarray.
Oh, subarray. No. Oh, we have to return the subarray?
No, length. What is the length of that particular subarray?
Okay. Got it. Okay.
So can we not use that Kazan's algorithm here?
Okay, maximum. Yeah, that is used for this only, right? Maximum sum subarray. That is, but maximum sum. Okay. They'll give this. Well, that's a good point. Like, but here you have to find the size, right?
Can
And that
we
was
like
we can use cadence also. We'll just have to take a variable called counter, and as soon as we hit it, as soon as we find the maximum sum, we'll just hit the counter +1. So we'll just find the maximum value of counter. But that also.
No, they are not telling for maximum sum. So they are just telling if you can satisfy this sum, right? And shortest window, what is available.
Subarray with a given sum, right?
Subarray with a given sum. There it's like maximum subarray, right? In cadence, I think, as far as I recall.
Yeah, that is.
so can we do like in a map we can store the like basically cumulative sum we can store till a index, and let's say we are at 5th index, we can check like basically what is the value cumulative sum at 5th index, then minus that particular k, and whether we reached that particular sum at like previously, and if we reached, then the difference like at the index at which we reached, and the difference of this index that should be my like one of the subarray.
No, but the problem is whenever you try to shrink the window, let's say you are at this point, you want to shrink it, right? So what will happen? From the prefix sum, you will try to remove this. So rather than removing it, will be added because of this negative sign.
No, like I am saying like let's say I stored like I am storing cumulative sum in my map. So there is 2, 0, like basically at index 0 it is 2, then at index 1 it will be 1, and at index when I for basically I checked basically I went to first index, I checked my cumulative sum is 1, my k is 3, so I will check -2. Basically I reached minus, okay, but then I have to search for 0 to basically all the numbers till -2, in minus infinity
Exactly.
to minus. Yeah.
So that will be kind of n square, I think. It won't.
So in that case, can we make a priority, but then also it will be open for every element?
Yeah.
Hmm.
Actually, if it's a positive number,
What
you
your
have a
thought process?
similar problem,
Hmm.
as
Go
I
ahead,
have
go
shared on the chart. Okay, but it is negative number, right? So that's why the problem is coming. You cannot do a straight sliding window.
I think that true.
Correct. Yeah.
Otherwise, the trivial approach of sliding window should have worked.
Yeah.
I mean, even this hash map should have worked. The one, I don't know, some speaker was mentioning regarding it, right?
Okay. But hash map may work, but the time complexity will be too huge, right?
Yes.
Yeah, so the way he was saying, if you can actually do it in a map and then do a binary search on it, because if you use a tree map, right?
Like, yeah, we can use tree map for getting the floor and basically floor and ceiling for that particular difference. So, but that will be a log n for everything.
No, but there is a solution with binary search also for this, using map and binary search. I mean, I haven't gone through, but if anyone who knows. Yeah, so then one other thing, like this is somewhat similar to what you say. See, what are the problem when we were trying sliding window, right? So whenever we try to decrease the sum from the prefix, this will get added, right? This is one problem. Secondly, when you try to increase your right window, I mean right pointer, you might not get always the increasing sum, right? It will decrease also because of this negative sign, right? So we need to maintain some data structure like which can keep track of increasing frequency, not frequency, prefix sum. So kind of monotonic queue, so that if something is outside your window, like you can remove it out from.
So kind of a maximum until every index.
Yeah, you can say that.
Okay.
Increasing sum, yeah, maximum that also. So I'll show you, like, let's walk through this example, right?
So can we use two-pointer approach also in here?
How? Go ahead. How?
Two-pointer approach as in initializing a pointer, which will point at the starting of the array, right? And just taking another variable called sum, and what we'll do is we'll just iterate over the array, and we'll just iterate over the array, and we'll just add the sum, right? And we'll just check whether if the sum is less than or equal to s. So we'll just have to no.
It is order of n square, right?
Yeah.
Every possible combination.
Yeah, all
Also,
the
like
possible.
two pointer will mostly work.
Just a second.
Like basically most of the time two pointers will work in like sorted thing or something, like in which we have some pattern, right?
True. Yes.
So in this case, because of negative numbers, that logic is also very tricky to use.
Really,
right?
exactly. Yeah.
Correct.
That's the only problem here. Otherwise, this problem is a normal sliding window.
Yeah.
Yeah.
So you are trying to come to the point like using monotonic queue is the only best way to solve this problem, right?
Yeah, and one you mentioned, I think binary search using. I haven't gone through that, but that is also one of the solution.
Yeah, but that might not be very efficient at the time complexity wise, even though it might be okay, isn't it?
Like what how much we are targeting, basically n log n or n like
No, single n. I mean linear.
If you can
Because
get,
you can't. Linear.
Let us see what the constants are.
Constant 10 raised to power 5.
Okay,
So
so n will usually work, n log n also should work, right? Yeah.
Should work, yes. But n will be much.
N square is too much. Yeah.
That's too much.
Okay. So then the monotonic queue is the only efficient way. So in case we get a problem like this and we have negative numbers, then we have to be careful, go towards monotonic queue.
Yeah, that is what the pattern I think we are learning from this question, right?
Okay. Now, if it's
Or-
monotonic queue, how would we implement it?
True. So the reason behind keeping this monotonic queue, like we'll always have the increasing sum. So what I'm doing actually, I'm first creating a prefix sum of this array, right? This 0 is just for the base case. Then you'll have 2.
Hey, can we take a different example, because this is a very small one, right?
Okay.
You can do that. Okay, I'll give you one which was failing in one of my test case. So
Okay.
which is 56. You can,
Let's-
yeah, we can use that also, the first one, but after that we can use another one. Like I'll just,
Okay, you can put in chat. And
sure,
pick it.
I'll put that, yeah.
And your k is here 3, right? So here what we are initially your DQ will be empty, right? So you'll just push 0 over here. And now what you will be doing, now when your pointer comes here, you just try to check, like, see, this is the prefix sum till the index 1 and this is the prefix sum till index 0, right? If you subtract these two and you find that that sum is greater than 3, that means the number line between these two is a valid subarray, right? That makes sense, right? So, but which is not the case over here, right? I mean, 2 minus 0. 0 means like first index you have to check of this, what do you say? Of the DQ. At 0th index, what is the prefix sum? 0. And at the current index, what is the prefix sum? And subtract these two, which is 2. So 2 is lesser than 3. So still you are not getting any valid array. And now while pushing this index, I'm pushing index in my DQ. Make sure that the sum should be increasing, then only you should push. Since this 2 is greater than 0, then only I'll push 1, right? And now comes this. What is the index? Till at this point, the prefix sum is 1. And at the 0th index of the DQ, the prefix sum is 0. And 1 minus 0 is 1, which is still less than 3, right? So, so what will happen? That means you didn't get any subarray till now. Now you will see, should I put this index into my DQ or not? You shouldn't, right?
A question.
Go ahead.
So we are looking for a subarray. Why we are finding a difference from the first index all the time? Like the first element on
The
line
sum should
26.
be minimum k, right? So that's why you are
Yes,
subtracting.
but if we have included 2 and we decide to include 1, then we should be adding and looking at them, right?
So
Why
this
are we
is-
subtracting? That's my
No,
point.
the second array line number 28, we are keeping the index tracking, not the number.
index,
sum.
this is index. Yeah, this
No,
is
but
index, not.
how we are coming to that point is you're saying 2 minus 0, 1 minus 0.
Yeah,
Why
so see,
we
this
are-
is the, okay. This is the prefix sum, right? Now let's say, I mean, saying here, the entire array is an example of the valid subarray for this sum, right? So how what you are doing? So whatever the prefix sum at this point and whatever the prefix sum at this point, if you subtract these two, then you will get this entire prefix sum of this array, right? That is what I'm checking, whether that will be equal to 3 or not.
Yeah, so usually what he's going to do is whatever the index is at the front of the queue, whether it is a 0, 1, 2, 3, that doesn't matter. So that he's comparing, because that will give you the maximum length.
True.
But we are looking for a minimum length, right?
No, a valid window, we haven't got valid window till now. Once you get it, then we'll flush it from the front of the queue.
Maybe you can complete this example. Yeah.
Sure. So we were at here, right? So here the prefix sum is 1 and at 0th index, the prefix sum is this. That means you are looking at this subarray, right? The sum is 1, which is lesser than 3. So that means this is not a valid state. Now, this index is what? 2. Now, before pushing 2, you need to check whether the previous, at the index 1, if the sum is increasing, then only you are supposed to push, right? So 1 is lesser than 2. So you'll have to remove this and then put this index, right? Then only it will be a monotonic sequence, right? You add at 0, you have a sum of 0. At 2, you add a sum of 1. Now comes the 3. Now 3 minus 0 will be what? 3. That means this entire array you are picking, right? So that is equal to 3. That means you got a valid subarray. So since you got the valid subarray, at this point you can record its length, right? So this 0 minus this, what will it be? 3 right? 0, 1, 2, 3, right? So for this you'll have a subarray of 3 till now. And now what is this? What do you say? It's an increasing sum, right? So you can directly put 3 over here. Now you're done with this 0. Next time you shouldn't use it, otherwise it will give you a maximum. So you need to remove, flush out this, and you're over with the array. So 3 will be your, what do you say? The valid subarray.
Yeah.
Right?
Santosh, give one example here.
Yes, Santosh, what is that?
Yeah, 57 minus 21.
20 up.
I haven't
56.
got.
I just copied it in that.
In the
because
chart he mentioned, second chart you can see.
Maybe I'll recopy it. Okay. Yes.
Yeah, post it again. I think I'm not.
Okay.
Okay,
just-
okay, got it here. Yes, no problem. Yeah, but sum of 63, right?
Okay. Yeah. So that will be a huge calculation, right? Anyway.
Yeah, no problem. We can deal it. So initially, what will happen? Your sum is k is your 63. So you will put initially 0 because the index. Oh, you'll have to do the prefix sum first of all. So let's do, no problem. So this will be what? 0 we are putting. Then you will have 56. 56 minus 21 will be what? 615, 45.
It is
14.
45.
no 35,
30,
right?
sorry, 35 it will, my bad, yeah. 35 and 35
Oh,
plus
sorry,
56 will
35.
be 85, 6, 91, right?
This is
91 and
91.
35, 516, 126, this one, right? And 126 minus this will be 117, I think.
170.
No. 9. Okay. 170. Right. Yeah.
That's fine.
Uh-huh.
Now what will happen? So this is your Q, I mean DQ. So 0 I pushed initially. Now you read at this point. So 56 minus 0, the prefix sum, I mean, what is this? 56 only, which is less than this. So there is no point in doing anything. Now you put this index here because the sum is also increasing, right?
Right.
Now let's go on this. Now at this point you have a sum of 35. So that
Yeah.
means even if I include this, you won't get a proper array. I mean, the required subarray. So now you'll see whether, and this sum is decreasing than this one, the previous one. So you
Right.
need to remove
that
this and put a 2, right? Now you come to 91. This is a valid window you are getting. Now, since it's a valid window, you record its length, right? So what will be the length? 0, what is this? 0, 1, 2, 3.
Yeah, it will be
3
3.
minus 0 is what? 3. As of now, you got 3, right? 3 as a valid length. And
One is 3, another is remove 56 after 56, it will be reduced. So you cannot remove 56.
I didn't get.
You now pop out the 0, right?
Yeah,
You
this will
update the
pop.
length, pop out the 0.
And this will
Now-
be, what is this index? 0, 1, 2,
This
3 will
will
be
be-
pushed.
Yeah.
But you have to record 3 and then you pop out 0. Yeah. Okay.
Yeah, I have recorded the 3 here over here. Yeah.
Uh,
Now
but,
120. Go ahead.
But this should be 1, right? First one, right? It is not 2, right?
No, because minus
No, no.
21 won't come to that, no?
Yeah, this sum is lesser. No, you need to maintain a monotonic increasing queue. So whenever this comes, it will flush it out. This end.
Yeah.
Oh,
But
okay.
That we have
Got it.
removed earlier. Yeah.
we are at this place, right? 91. So 91 minus front of Q. So front of Q is 2. I mean, at 2 position, you have to see what is the 0, 1, 2, 35, right? So 35 minus 126, what is that? 91, right?
35 minus 26 will be
91.
91.
So 91 is a valid one, right? So if it's a valid, and length will be how much? This index is what? What is this index?
4, no?
4 minus
4
2,
minus
2.
Mhm.
It
2.
will be 2. You'll update with 2, and you can push the valid index 4 here, right?
Okay.
Because sum is increasing. And now comes 117. So what you will do? 117 when it comes, this minus, okay, you'll have to remove this because
Pop
you're
out 2, right? Yeah.
so 3, 0, 1, 2, 3. This 91 minus 117. How much?
Yeah.
21.
Yeah. So
Uh,
that is lesser.
26.
26.
Yeah, that is lesser anyway,
That one.
right? Yeah.
So, which is not a valid one, right? So that means this is the recorded window you got.
Yeah.
Yeah.
Hmm.
So
Yeah, so
therefore your 2 is the right number.
grammar, yeah. So basically 2 things we are, whenever such problem come, first of all, DQ will hit, right? After this. And secondly, that DQ should be monotonic increasing kind of, right? And the intuition behind is that like in the normal, what do you say, whenever you're using normal sliding window there, your sum can increase and decrease. So increasing the right might not give you the correct window,
Yeah.
right?
Well, okay,
That's
there are 2 things. In this, we have to use a Q, which will be a DQ.
True, yes.
Right, so it's a double-ended queue. You can pop from the front and the back. So people are asking in the chat, why are you popping and when are you popping? So I think when are you popping from the back? So whenever
I'm not popping from back, only from the front I'm popping.
yeah, means you are removing. No? You
You
remove.
are also. if
Only
you-
whenever you find that your previous sum is less greater than your next, that means you need to remove all these things. Like, I mean, all those
So
indexes
here
which are
also you
available.
popped out while inserting the index number 2, right? So
Okay.
popped out the 1 also you popped out, right? From the
Mhm.
beginning also popped, right? Because
Yes.
this one is greater than 35. So you have to make it monotonically increasing. So it popped out 56 index from the list, then add the 35 index in the queue, DQ.
Yeah. And second reason, once you get a valid window, you need to remove that the index, I mean the front of the
Yeah,
queue, because
yeah.
you're done with that length, right? Because next time, even if I take another number and calculate the length, it will be bigger one.
Okay.
So better to.
So you are popping from the back only when your prefix sum is lesser, which is in the queue. And now you are getting a bigger prefix sum, then only you are popping from the back because you are getting a bigger value in this case, isn't it?
Yeah.
So then you pop from the back, but when you pop from the front, so in that case, you are trying to minimize on the size of your sub array,
Yes.
right?
Yes.
So those are the two conditions what you are doing.
But Santosh, when are we popping from the back? I didn't see.
Back no, front, I think only I'm popping. I didn't see.
No, you are removing. No, see when you come to 35, see when you get 56.
Okay.
Yeah.
Got it. Yeah,
When you
monotonic
get-
sequence for maintaining. Yes.
Right. When you get 35 and then you have 91. So you will have to pop up 35, right?
True. Yes.
So because you still want a bigger one because the sub array is increasing now, which is of your
Yeah.
required K.
Yeah. So actually, if you will not pop out 56, what will happen? So it will be get the value greater than K. Okay. We want to reduce the sum greater than equal to K. Okay. So that's why pop out 56 here. Index of 56 here. So that if you will keep the 56, there is no harm. It will work. But thing is that by logic we cannot process 35 because the logic is that once we check it is the delta is smaller, right? We bail out from there, right?
True.
So just to compare 91. Okay.
Mhm.
Suppose now we have we have the queue have contain index 1 2, then we are processing 91. Okay. So 91 we process 56, right? It will be 0. It is lesser than that value of 63, right? So we are not popping out 56 here. We keep it 56, but actually pop out 56 index, then we can process at 91 with 35. Right. So that's
Yeah.
why you are removing that 56. That is the main reason.
Makes sense. Yeah, so I'll just walk it. It's the same thing what we did it. And,
Yeah, there are some more discussions in the chat.
ahead, yeah.
Can anyone speak out? Actually, I see a lot of things happening. It will be better because
Yeah.
when Shashank is presenting, he won't be able to see the chat, right?
True. I think they are discussing this brute force if O of n square is acceptable using a matrix.
There is-
Okay. Can
Yeah.
you please explain this if possible?
What is want to say is that sliding window. Okay. Sliding window sense like you have done a palindrome thing, right? Palindrome we check find the maximum palindrome in the string. Okay. So similarly, we keep on the sliding window, keep on increasing, and check which is minimum window size, and we get achieve the value of K. Okay, so he want to mention same thing. It is order of n square time complexity. So we maintain a window size something like that. So in window size, start with 1, then 2, then 3, then 4, and still the size of the number. Okay. So if we achieve when the sum is greater than equal to K.
Yeah, then we start decreasing. Yeah.
Not decreasing. We already processed the decreasing one. Just update window size, result size is equal to minimum of current result size and minimum window size. So we keep on processing like that. So it will be order of n square. We will take the matrix, but it will work and extra space also there. Okay, of order of n square space as well as n square time complexity. Both are there.
Johra has posted one more solution where it's a sliding window, keep increasing and decreasing. Looks like that can work, right?
Yeah, sure. Go ahead, share it if Jora,
Which
like if you.
one Jora said?
Yeah, Jora, can you actually
Yeah, sorry.
share your
Yeah,
screen?
yeah, it is what Sasang did same thing here. But Sasang, in a Sasang solution, we are doing syncing the slide window, both back side and front side, okay? In Jora solution, he's syncing the window from the front side, not in back
Yeah,
side.
exactly. Not the
Yeah.
back side. I'm taking only.
Yeah,
Can,
it
can
will
you
be-
can you share your screen if it's possible, Jora?
Yeah. Share my screen. Actually, I'm not on my. Yeah, just a second.
But it will be
Or-
TL. I have experimented this solution.
Achha,
Let's,
you have
let's,
experimented.
let's see.
I
Let's
have,
see what he has to say.
I have tried on it and it was working fine with the example test cases, but I haven't tested it for the test case that
Full
you
test
gave.
case will be TL. Yeah.
It will TLE.
Yeah, it's an N square kind of like, oh, can you into an.
Not N
I'm
square,
No, no,
actually.
it's square.
Matlab, it's not. It's technically not N square. Matlab, it's technically not N
No,
square.
it will not work for all solution also. What?
But let's walk through what he's saying. Yeah.
Yeah.
Yeah, so there is
Santosh
taking
said the
the,
example, right? With that, it will not work.
Okay.
the typical sliding window is doing. He'll keep on increasing the height till the point he gets what you say the required sum. Once he gets the required sum, he starts. He'll record that window and start shrinking that from the. But the
this
problem here is no, this will not work because if you get a minus
It will
number,
not
minus number, yeah.
it will get added. So that's the problem we're discussing right at the beginning. That's why otherwise it's a very, very nice solution, right? I mean,
Yeah,
at
it's
the
straightforward.
numbers.
It's the best solution for a
And
sliding
this
window. Yeah.
solution will work
Exactly.
for the link I have shared. First link I have shared, this will work for that solution.
Can we
Okay.
add if condition in line number 31? If it is minus number, then don't add kind of.
No, but in this
Matlab,
case,
we
your
can-
K is different, no?
How will you take sub-array then? I mean, in between, if
Oh,
negative
okay.
comes, that's the problem, right? This will not work. You are trying to reduce the sum, but when negative numbers comes, it will start increasing.
It will start exactly.
So the negative number makes this whole problem very tricky.
Yeah, exactly. This.
Yeah, and even the constants, if you look at it, the constants are also very different. 10⁵. So therefore, n square won't work. They have given that in a very borderline. N square will be 10⁻10, right? So it won't work at least for lead code. It will
Yeah,
TLE.
if we'll have to think of a solution either in n log n. N log n can work.
Yes, absolutely. Yeah, it will work.
Log n can work, but n square definitely that will 10 keep part in, so that will to give TLE.
Yeah. So only binary search or binary search maybe slightly.
Binary search, linear approach or n log n kind of.
Yeah,
approach.
yeah. At least it will come, it is slightly intuitive than this one, right? The monotonic queue. But the monotonic queue is a very good pattern, which will help you in many such cases.
Even the sliding window maximum problem, they also use monotonic queue, right?
Right.
There for every window, you have to find the maximum number.
So then only the question becomes when to pop from the back and when to pop from the front. You will have to use it very wisely.
Yeah, let's switch to next then. If
Okay.
we are done with this. Yeah. TLE is time limit error. Siva is asking. Yeah.
Okay, yeah. It will take more time to process. I think 10⁻10 will take more than 1 second or something like that as per the lead code.
Yeah.
And there is a TLE, there is a MLE also, memory limit exceeded.
Yeah, you cannot have.
Even there is SLE also, segment fault error, segment limit error, something like that.
There is heap overflow will also there if you call multiple times.
But you get an exception in that case, right? You don't.
Yeah, it is runtime, compile time exception is there. No, runtime, sorry.
Yes, there is SLE. Go ahead.
Anyone got SLE these days? Like I never found. I used to get 2 years back that time.
No,
Maybe you are implementing very efficiently, so you're not getting it now.
I think in C code only I used to get that SLE. In Python you won't have.
Okay.
Because pointers are not there in Python, right? It's a normal plain English.
What is SLE full from?
Segment, no, segment error they gave. Segment limit.
Out of bound or exception. I think in C it comes. For out of bound exceptions, segment.
Is SLE anything different from 6F? is SLE anything different from segmentation fault?
I think
Oh,
it's
no,
not a
it's the same,
segmentation
like
fault, right?
segmentation
So
fault.
that should be an exception, I would say, not a SLE or
Okay.
something like that. Yeah, but maybe I'm wrong. I didn't see that though.
No, you're correct. Yeah, that's a segmentation fault only. I checked it in Google. Some segmentation schema limits there. Okay.
Mhm.
I have seen MLE and TLE. SLE I have never seen.
I also am not seeing. Yeah.
Yeah.
Okay,
Let's
no
move
worries,
to
yeah.
next. So next is like smallest range covering the elements from K list, right? So you are given a list, K list of sorted integers, which are in non-decreasing order. You have to find the smallest range that includes at least one number from each of the list. And this is defined. We define the range AB, smaller than CD if this condition suffices, or if you play with the inequality, you will come to this. Right? Like these are the lists.
Go through the whole
Hey.
example.
Sure. So this is the
Shashank,
yeah.
there is a suggestion in the chat, and I think that makes sense. Please consider if you can. It's like, go through the problem and then basically give 5 minutes or so that everyone can think about the approach, and then we can have a good, healthy discussion.
Yeah,
Just because of the time crunch, I'm not doing. But from next time, like I'll pose the problem in the. Okay, let's proceed.
Okay. Yeah.
Because of the time crunch, yeah.
Yeah. Okay.
Anyway.
Next.
Okay, let's so this is the array given to you, right? List of, nested array, and this is the output. The reason is that each of the numbers, if you find from here, like 24 lies here, 20 lies in this, and 18 and 20, a single element lies, and this is the shortest range that is possible, right? And if you look at this 1 to 1, like, 1 is present in everywhere, so this is fine. Here 10 and 11 is fine. Here both you have to take, right? And here 1 to 7, all are single elements, so you have to take this range. And they are in a non-decreasing order, and this is like the value will go from minus to this, and length won't be greater than 50.
So we have to find the range that includes all the elements in all the arrays.
At least single element from each list. Like from here, at least one element should be included in this.
Okay.
Not all. If it is there, it's okay, but minimum like one should be there.
But in the first example, 20 is there, but the first array doesn't have 20. So
24 is there, yeah.
No, 24. 15 to 24 contains 20. That's why we are adding 20, right? That's the reason.
No. The array has 24, and we have 24 in our output.
Oh, got it. You're right.
But why are we choosing only 24?
Because
that gives the shortest range, right? Okay, let me draw it on a number line. It will make more sense then.
Yeah.
So if we draw like this a number line, so what is there? 0 is here, right? Let me write with this. 5 is here, 9 is here. 9 this. Then any number, 12 is here. Sorry, 10 before that. Before 10 anything, 12 is here, 15 is here.
And before 4 is there.
Okay, 4 is there. I'm including it here. 15 is there. Anything else? 15 after
24
right?
and 26. Okay.
18 is there. 18 is there. 20 is there. Then 24.
26, 30.
30 here, yeah. So so this window I'm capturing 20 to 24, right? This window. I think one more number will lie between 20 and 24.
Sorry, why not 23?
23 is not a number in your list, right?
22.
Ah,
20,
okay.
22 is here. Thanks. Yeah. So all three numbers are covered, one from each end. And this is the shortest range, right?
No, okay, see, I got, so what you're trying to do is you're trying to put all these numbers from all that arrays, right? But what we have to do is we have to take a first only least, right? And then keep on developing this range, isn't it?
True. Yeah, I'm just saying, elaborating this example. Yeah, that's what it is.
Or the brute force way you're saying.
Yeah.
But then how did you come only to 20 and 24? And why not the others?
And 20 is not present. Okay.
Go ahead.
It's not present in third array, right? How we are excluding the third array. Like 518, there is no 20 there, and
It's 22.
22 is there.
oh,
Right.
okay, yeah, it makes confusing. Okay, I got it. Sorry.
No, I also got it now. Yeah, because
Okay.
22 is there. It is between 20 and 24, and then you have included 20 and 24.
So the answer is like 20, 21, 22, 23, 24. So it contains all. Yeah.
So, okay, if let's say if I capture this window, what you say, 0, 9, okay. If I capture, if I start from 0, okay. If I capture this window, 0, 4, and 5, right? Still all the elements are covered, right? No, not. It's not covered.
Yeah, because
Yeah.
4 is there in the first list, 0 is also there, and 5 is also there. 5 is in the
Okay,
third list.
it's covered then, yes.
So instead of doing it like this, okay, so you can create a multiple row, okay. So it's just to have to take intersection part.
Yeah, that is the main. How will you do that?
Will you do that? Then it will be clear to everyone. There are 3 row, right? So you get 3 row of 3 row. You can 3 line you can take and take the common intersection.
So max and mean for this is mean is this, and max is 26, and for
Right.
this one this is 0 to 20. My 20 will be here and your 0 will be here. Next is 5 to 30, so 5 will be here and 30 will be here.
Yeah, right.
Now you have to
then you have to take the common intersection part, right? Like this.
Yeah, that makes sense. More illustrative it is, yeah.
But okay, but we are ending at 20. We have to go till 24.
You can take, I mean, it's not like common, it should be. You can take this part also because everything is covered between these two ranges. I mean, even if you are at this point, from this point to this point, everything is covered, single element of it. It need not
so
be.
we have to
that
take
all
the
the
minimum from that. Yeah, okay.
True, yes. Because here you are missing third line, but still this element is covered in this range, right? So that's fine. Yeah, so I think somebody was like, what are the ideas like we came up? One way, like, okay, let me then. One way would be like the normal, how you do the sorted list kind of thing, right? Like this 4, 10, 15, you have 24, you have 26, you have, right? And 0, 9 is there, 12 is there, 20 is there. Then you have 5 is there, 18 is there, 22, right? So what you can do, you can keep 3 pointers over here, just a brute force, I'm saying, not the the trivial way. So one range would be what you can pick from 4, 0, 5. This 4 to 5 could be one possible range, right? Where all one elements, sorry, I think 0 to 5 this will be. 0 to 5 is one such range which will pick all the elements, right?
Yep.
Now you have to shrink this range, right? So this is your 0, this is your 5, and here is 4, and let's say here more numbers are coming. So what you will do now, till now you have chunked this part. Now if you have to shorten this range, you will shift the left pointer, I mean the pointer which is at the lower bound, right? This bound at the minimum, that you have to shift it, right? Then only it will become shorter, right? Because by shifting the right, you won't get a shorter, the window will increase only. So you have to short this window, you need to move this pointer to the forward direction. Let's say somehow, let's say here, let's say 6 windows here, and something like that we moved and we got 4, 5, 6. So this is a better window because the difference 4 to 6 is 2 only, but 0 to 5 it was 5. Something like that, right? You're getting what I mean to say? Or
so you're trying to use the sliding window approach.
Yes,
the
sliding window.
General sliding window. Okay.
True. So what I'll try to do first, I'll take all the 3 elements. Like I'll keep one pointer P1 over here and P2 over here and P3 over here. Now P1, P2, P3, and then I'll check what is the, I mean, among them, what is the, what do you say, the maximum and minimum number. So maximum is 5 and your minimum is 0, right? So the range 0 to 5, initially you got a 5 range, which will contain all the elements, one element from all the array. Now I have to shrink, I have to find in which array the minimum element was lying, because by shrinking the minimum only you can get the, what do you say, the smaller window. Now I'll hit this point, right, to the 9. Now when you hit 9, now again you find between these 4, 5 and 4, 9 and 15, what is the minimum? Minimum is 4 and your maximum is 15. Sorry, this is not 15, this is 5, right? And maximum is 9. So 9 minus 4 is still 5. So there is no change in the range, right? Now what is the minimum among these three? This is the minimum. Now you'll pick 10. So 10, 9 and 5 now you'll have, right? So out of this 10 and 5, the minimum is 5 and the maximum is 10. So window is still, what do you say? It's 5. Now you'll move to this. Now you'll take the minimum and maximum in this. So minimum is what? 9. Maximum is 18. So this window will give you 19. So it's not good. Now you pick these numbers. This one. So you're getting what I'm trying
So this
to say?
is the brute force, right?
Brute force, yes.
Yeah.
So keeping 3 pointers on all the list, find the max and min, and in whichever list you find the minimum window, you increase the pointer.
Basically, we might end up going to, it will be n cube, like not n cube, but
It will be not n cube, linearly you're walking, right?
yeah.
So n into k it will be kind of, you can say.
Okay.
Number of elements in each list and k such list are there. So almost you can say equivalent to n square if k is equal to n.
Okay.
Kind of, yeah.
Shashank,
So this is clear. Go ahead.
I did not get the intuition. Like you're keeping a pointer for each and every array, calculating the minimum and maximum. Till there I got, but I did not follow the.
Okay. So initially we took, okay, let me change the color. Let's take this color. So initially you took this 4, 0 and 5, right? I mean, pointers are on P1, P2 and P3.
Yes.
Make sense?
Yes.
Now, what is the minimum here? 0, right?
Correct.
And what is the maximum? 5, right?
Yeah.
So difference of 0 and 5 is what? 5. So the range is from 0 to 5, it will contain one number from each of the list, right?
Correct.
Correct. Okay, now you have to shorten this list, right? So if you plot it on a number line like this, 0 is here and your 5 is at this point. So how will you shorten the window? By moving the minimum only, right? I mean, if you fix the right at this point and you move this minimum, then only you can decrease the size of the window from the earlier. Make sense
Yes.
or not?
Yeah.
Right.
Correct.
So that's why I am only moving my pointer in that what do you say?
Array, particular array.
Where you have the minimum element. Now my 3 choices are what? 4, because this is fixed, 9 and then 5. Now out of them, what is the minimum? 4. And what is the maximum? 9. So this is 5. So it doesn't make any difference. I mean, earlier also we had 5. Now you will try to move the window where you have the minimum. Minimum is 4, right? Now you will move here.
Correct. Yeah, got
Now
it.
again, this is the same thing. Now for doing this thing, what I'm doing, I'm moving 3 pointers, but easily you can get one more thing here, right? What is that? Heap. If you use a mean heap to just get what is the minimum, then you can easily do this problem, right? Does this, whichever you get, it's like merging k sorted list.
Correct. Yeah, that is what the pattern repeats.
Can I ask here, if we use min heap, how will we know the maximum value? As I understand, we need to know mean value and maximum value as well, yeah?
Yeah, both we need actually. That's what I'm thinking. Max
No,
is
not the max. We just need 1 from that array. Even if you take the first element, that's fine, right?
No, we need both, right?
We have to take both. No. See, when we have to take both. Then only you will calculate the difference.
What he's trying to do, I think, he's trying to take the minimum value from the priority queue, which will be the min heap. But when he's pushing at that time, he will check what is the maximum value.
Record it, yes.
Yeah, so there will be 2 ways to do it. No, not 2 ways. That we'll have to use both the techniques to get minimum and maximum.
To track the max. I'll show you the code here, but the concept is this only. If any query here, then it's fine, right? Salvi?
Yeah.
Okay. That's the same thing we're trying to do.
Somebody can explain it.
Go ahead, Shreyas.
Somebody explain. Please, it's difficult to follow somebody.
Okay.
What? Can you speak Zoho? That will make more sense. Like which area?
You're writing on top of the page itself, right? So it makes difficult for people to follow what is being written on top.
So
easily move to a different.
So if you can copy all these nums, they're asking us to actually with the approach which you did on this screen, if you could actually explain it. Yeah, just copy it and
Okay.
do a sort of site of walkthrough.
Sure, definitely. So
Yeah, just do it here without the code, and then you can walk through. Now you pick like 4, 0, 9 on different number
lines.
lines.
Okay.
Yeah, so
So
you
one
can.
is this line, another is this line. So interject at the point where you feel that it's getting difficult, so that
Sure.
I mean on the fly we can clear it here. And this is your 4, right?
Mm-hmm.
Yeah. So what I was doing initially, I was keeping one pointer at this place, one pointer at this place, and one pointer at this place.
Okay.
And
so now you take those 3 numbers outside somewhere,
True,
maybe in
true.
the next
Just
line.
assume that there is array only contain only one element, okay? So
Right.
what will be your range? You take a 0 and a 5, right? Then it will cover all the numbers.
Mhm.
And
So
zero,
he's
जो आगे बोल
pushing
रहे
this
follow?
in the priority queue now.
True.
Yeah.
I'm putting it in the priority queue now. So priority queue will give you the, I mean, you'll have to push the, list of the index also ID, like from which list you got this particular 0. Otherwise, how will you make sure that in which you have to move the pointer further, right? I'm just
Right.
showing you the simplicity set.
Yeah.
So 0, 0, you popped out. So you went to this array, right? And
Yeah.
now what you
Now
will do?
before popping out, just make two variables, minimum and
Two
maximum.
variable, yeah, max
Yeah.
and minimum.
Max and min. And the max you say when you are pushing 0, 4, 5, you found out 5 was the max. So you made max as 5. And now
Min.
at the top of the priority queue will be the minimum value, which will be 0. And therefore your min becomes 0, right? So
Yeah.
your range is 5. That is fine. Yeah. Now you go for it.
9. Now I'll put 9.
Yeah.
Now
So
the
why you
max
put
will-
9? Because your 0 was on line 28, which was the second one. Therefore, you are actually removing that, and now it advances to 9.
True.
Yeah.
Now this doesn't make difference in the answer. Max and min difference is still 5. So
yeah, 9
we are
will
fine.
actually be pushed to the end of the priority queue now.
True.
Because
Yeah.
it's a min heap, right? So 4,
Yeah.
5, and 9.
Okay. I'm
No, keep it there. Otherwise, confused for you, Sasang.
No, that's fine. Yeah.
Index 1 is for.
So then you have to maintain the
location.
index there also, right? Yeah.
So keep it there.
Okay. So now this is done. 9. Now minimum number is 4. So where is 4 here? So what you will
Yeah,
do?
10.
10. So just remove
No,
this.
no,
and
no. For 9. This is 4, right? 1 second.
So 4 should have been
Oh.
before 9, no? Yeah.
Okay, I'm not following the exact. Okay.
Yeah, so
5,
you will get confused with
5, 9, and 10. Yeah. This is fine, right? After heapifying, this is the.
Yeah.
I heapified it here. So now you got 9. Now what is the max? Max is 10. And your mean is what? 5. So 10 minus 5, still the answer is same. So it doesn't make any sense. Now what is minimum? Minimum is 5. So you'll go to this window and you remove it here, and then you'll have 18 over here after heapifying. Now what is the max? 18. What is the min? Min is your 9, right? So this is greater than 18 minus 9 is, which is greater than 5. So again, we don't need to update.
Changing that, yeah.
Right. Now minimum is what? 9. 9 you got from this array. You'll push what? 12. So 12 you push here. Now your this is, and min is 10. This is 18, difference will be 8. So which is again not a valid one, right? So now what you need to pop? Minimum is what? 10. 10 you got from this one. So you'll have to 15 you'll push. Now max is 18 and your min is 12. Right? Sorry, this is 12, which is 6, which is again not a valid answer. Now 12 is the minimum. You just remove this. Now comes 20. 20 will go here, right? Now 18, this is a good one. This 20 you will get, this you'll have 18, and this will be 2.
15.
Okay, sorry, yeah, this will be 15.
You won't get 2 there, right? Yeah.
And then 5 it will be. Now 15 gone. Now 24 comes, right? So this you got 24, 18, 20, and then 24. So max is 24, and your min is what? 18. So this is 6.
Sorry,
6 is again, it's not a valid one, right? Go ahead. And now what will happen? 18 will be popped out. 18 from where did, okay, 18 you took from here, third array. So 22 will go, which will reside over here. Now max is 24 and your min is 20, which is, sorry, this is 20, and this is the 4 difference, which is better than this, which will push here, right? It's fine. And
So
now,
even if you proceed ahead, it's not going to give an efficient one.
Overall, you might have got the flow what we are.
How do we control that we have values from different ranges in our priority queue in min heap?
You'll maintain an index. I come again. I didn't get various ranges.
Yes, I understand. We need to have each time each value we have from different list. Yeah, in min heap. Sorry.
So
Right.
You'll
whatever,
maintain an index.
yeah, whichever value
will
you're popping, you are putting the next of that list.
Oh, next one.
Yeah, I+1 because this is a sorted array, no, right? So whenever you go on the forward direction, it will always be an increasing sequence.
Yeah.
No, I think the question is in the priority queue, we keep from which queue that number belongs to. So when we pop, we put the next
Index.
number from the same queue.
Right.
The question is how we are maintaining in the priority queue number from all the array, right?
You mean index tracking which array it is coming from?
Right.
So we can take a pair in that custom class
Yeah,
called pair.
yeah.
Where index and number will be the custom class variables.
Yeah, I think that was the question. Yes.
Yeah. So I did not get how we calculate the maximum. Minimum is like mini will take the minimum, but maximum how do you calculate each time?
Yeah, before pushing itself, you will whenever we pop element from there, we'll update with them. I mean, we'll keep two variables maintaining max at that.
But
while inserting itself into the what do you say?
See,
into the queue.
if it is a min queue, then whatever the number we are popping, that is the minimum number, right? But
yes, max calculation is difficult. Yeah.
How we
Okay,
are?
let me. I might have taken care of max. Okay. I'm making a list already. Like, okay, let me walk through this code. So this is just a heap I'm creating by pushing the first number and the index of the array, right? Like, this is the first number of every list. This is the index.
No, what is that 0? The last 0?
Yeah, I'm also
the list. Zeroth list.
No, okay.
No, it shouldn't be 0. Should it be?
Okay, no. This is the first number you picked from the first list. This is the index at which this 0 element is present, and from which list you have taken this is what.
Yes.
Okay.
First is index and second is which list.
List, yeah. Now you are heapifying it, right? The way we told you. And regarding the max for the given, what we are taking, we are creating a list. I mean, for every list you go through the nums and pick that first number, like 4, 0, and 5 was there. So what is the maximum number that I'm taking it in a list?
Okay.
So this is to get the maximum value for the region.
Oh, Shashank, you are not limiting the heap size to 3 here.
No. It's like I'm overall every. No. It's 3 only. No, first element from each list I'm taking, right?
No, I mean to say there are only 3 arrays, so heap size must be 3, right?
Yeah, heap size always be the size of that number of row.
Yeah, that is
So
right.
that we have to maintain.
Okay.
So while
That
heap
is what we're
size
doing. No?
is
So in nums there are only 3 lists, so only 3 numbers will be there, right? Heap size will be 3 only here, right?
but
Because
thing is that whenever this range is some of number of row, number of column of say number of number of element in each row is different, right? Then in this case, how are you handling them? Then heap size is going to
heap
be
size
reduced.
will, yeah, it will reduce in that case. I
But
mean, it will
I have written with maintaining always checking till heap size is size of number of row. If that is reduced, then I bail out from the loop. Okay, so I think it will work also. I don't know. I just run it. Let's see.
Okay, it should execute. I'm not sure.
Then I'll be changed.
No indentation error. Okay, this is because of this. I mean, these things we have.
Okay. Let me try also.
It's working.
Yeah, this is fine. Yeah, because usually it will be the first heap what he is populating will be the size of the nums array, because nums
True.
array is a 2D array, right? So he is taking the size of all the whatever the rows are, the number of rows, and therefore that heap size will be set that way. Heap PQ.
Oh,
Heap
you
Q.
don't always keep the heap size same number of row, right? That you are doing.
He is doing, no?
We are going
For the
through
first,
every.
see, for the on line 3, he's only taking the one element of each and every row. That is what he's doing.
But when popping out, right? If we popping out, then we are not adding.
You have to add every time, right? And every time you have to pop.
Okay.
Because
So
whenever
let's
you are
go
popping out, you will
down.
go to that particular list and then pop out, because that is the first element on the top of the list you will pop out. And then based on that index, you are going to push also. Therefore, the heap size will always be maintained as the size of the rows.
Okay. Okay, go a little bit
Yeah,
down.
let's go through the whole.
So this is the smallest range, like initializing with the plus minus infinity. And max and min range. Yeah. So now as long as the heap is not empty, so you just pick the, minimum element will get from the min heap. What is the list index and what is the from which list it was popped, right? And if the difference of this,
line number 15, you did the same thing here, because once it is exceeding the number of written directly.
Return this one. Okay, yeah, because that's a early bailout. What you were saying, yeah.
That's what I told. Yeah, got it.
Yeah, makes sense. Yeah, so if it is like if you found that new one which you have found is better than just update it, and this is early bailout. Like if you find that one array is over, that means there is no point in proceeding further because you'll be devoid of that element of that particular array, right? And next time, whatever index you have got plus one, you do the next number you pick, and that you put it back to the this.
Yeah, see, early bailout, the on line 15 is fine. It's an optimized version, but it is not required, isn't it?
No, it is required. Without it, it will get failed.
It is required. Otherwise, how do you know, like, if we are other index out of bounds will come if you are doing that, right?
Yeah, because I'm not returning anywhere other than this, right?
Yeah, if you traverse like that, you are reaching the end of the array and the array index out of bounds will come somehow.
Yeah, because it will try to access the element and element is still not there. So it might give array out of bounds, right?
Yeah.
But you need to return the range in this case, isn't it?
Yeah, I'll have to return the range.
So how are you returning that? Okay, you are always storing it. So
Updating
your smallest range, right? So, but if you come out of the while loop, okay, and then you return it, will that not work?
But that it's a good optimization. It should work. What you guys saying?
Yeah, that is what I'm saying. No, so it should work, but it might not be an efficient way of doing it, or maybe
it should work. I mean, but that's a bit early indentation. Let me see. So this.
Because if we see too much of optimizations, then it's slightly hard to follow sometimes, you know.
True, yeah. List index bound, yeah, that error. Oh, here we are accessing num. This will create a problem now.
Maybe we should change the line.
Instead of return, you have to write break.
Okay. Forget it. I think that's a slight different way of doing it. It's okay. Let us continue your way instead of actually trying to debug this. Yeah.
Yeah, I suppose we can change line.
I'm sorry.
Come again. What do you say?
We tried what I mentioned, right? What you mentioned, this line is valid, okay? If you remove that valid, then it will not work. So I tried here, it is working fine. Same approach. What you did.
Can you explain me that top sixth line? Or?
Sixth line. Okay, so here like all the first element of that we are taking of your three arrays are there, right? And what is the maximum out of them that I'm putting?
Oh, because the
It's taking
size
all
of each and every row is not same, and that is the reason you have to have this condition.
Yes,
Okay,
yes.
got it. Yeah, got it. My bad, I didn't go through that. Yeah, sure. I thought all the sizes of the rows were same, but it is not. Yeah.
Yeah.
But this can be an arguable question in an interview, right? Because he's not going to give you all the inputs, right? So he might change at the end and saying, okay, some of your rows are slightly in different size. Then how are you going to handle that? Then only you will come to this. But the normal logic will be without that also, right?
Yeah, without like checking.
Because we could start with assuming all the row sizes are same, and then we
Equal,
can
yes.
add a condition there to take care of it.
Mhm.
Because coming to this solution itself was not an easy task for me,
Trivial
at
task,
least.
yes.
Yeah.
Yes. No, that's true.
Mhm.
Nick,
Yeah.
to your question, size of the heap is not 3. We are
K. Size of
K.
heap is K.
Number of row.
Per rows, yeah.
Row can be how many are there? Yeah, K, right? Yeah, K.
Yeah, I think let's move to next one, the last one.
Yeah, well, the only thing is, if we have a time crunch, we should take only lesser problems.
Yeah.
Then
Oh.
instead of
9:30, we are doing one more.
No, let's leave it. I think we'll take it next day. I mean next time.
Yeah.
Yeah, it is better to do 1 or 2 problem, but deep drive is better.
Yeah,
True.
and let us give everyone a chance to, even because then everyone doesn't follow, then it doesn't make sense, right?
True.
Yeah.
True. So from next time, I'll take 2 problems at max, or
2
one
problem is fine. Yeah, even if we go more than 1 hour, slightly that should be okay, no? Or it's
Sure,
1 hour
yeah.
is a strict.
No, 1 hour, 5-10 minutes is fine. That's what I
1 hour problem
1:15.
is fine also if everybody follow because everybody thoughts need to be tuned here.
Right.
Exactly.
So everyone is in different mindset, right?
Yeah.
Understanding level for everyone will be difficult. Yeah.
True. I'll take care of that from next time.
No worries. Yeah. Yeah.
Yep, I think we are done.
Yeah, one more comment is that the other solution, right? I just the question before. The other solution is actually accepted. I'm not sure why. Maybe I just wanted to let everybody know. Okay.
What is shared by Johar,
Okay.
right? Johar.
Yeah. So let me share quickly the screen and
Please, yeah.
I just ran it. Okay, I did not do anything. Are you seeing my screen?
Yes.
So you're still sharing.
Code screen is not showing.
Yeah. Okay.
So this is it's the same solution, right? That was posted. Basically, there is a yes. So basically, we start with the int max as answer. Left and sum is 0, and then and this is accepted. So I was wondering why it is accepted, right? But we can look at later, or everybody can look at.
Oh, the question is, they are saying question is different. This question is different.
This is different.
Yeah.
Yeah, I
I
thought,
told you,
because
right, that this will work with this problem. I share the link,
Yeah.
right?
I see. Okay, that's right. Okay.
Yeah, because
What
was
the,
the-
but this
what
will not
was the
work for
question?
other problem.
Okay. So I think I took from chat. Maybe okay, understood. That's
Yeah.
right.
First link I share the link, right? That
Yeah.
so this solution will work for this link. It will not for
right.
Okay, understood. So
We
the
have similar questions like that, right?
Yeah.
Okay.
Understood.
only the negative number is extra added here. That's why extra special case is
That's
added.
okay. Makes sense. Totally makes sense. Thank you.
Good.
Yeah.
Yeah.
No, that would have been really a good one.
Yeah.
Unnecessary.
Yeah.
Yeah.
Yeah. Let's stop the recording then.